Welcome back. Today we will be talking about Descartes' rule of sign and upper and lower bound rule. So when we are talking about the Descartes rule of sign, we are talking about something called variation in signs. So Descartes' rule is based on the variations. And what does that mean about the variation? Variation means how alternatively the signs are changing. For example, if it is plus x minus 3, right? So we have a plus and the minus. So it is an alternate change in signs, or we can say two consecutive coefficients have opposite signs. Let's understand with an example. So we have x cubed minus 3x plus 2. Now, in this case, we need to understand how the signs are changing. So we have negative here and the positive with 2, but x cubed is standing alone. That means it has a positive sign. So we have positive, negative, and positive. So the signs are changing twice, from positive to negative and then from negative to positive. So we will say there are two variations. So based on this is the rule for the Descartes rule of signs. So it says if the number of positive real numbers is either equal to the number of variations or less than that number by an even integer. Even integer means, what is an even integer we are talking about? We will subtract 2. I will explain it more with the example. And the second rule is with the negative real zeros of x. It will be equal to the number of variations in sign of f of negative x. Right? We will plug all the x as negative x, and then we will evaluate how many variations are happening. So in the above example, there were two positive, or if I do minus 2, 2 minus 2, that means no positive. That is the meaning of the first rule. Equal to or less than the number of an even integer. So 2 variations or 2 minus 2, that means only 0 variation. So if I factor it out, I will get x minus 1, and x plus 2. So 2 positive real zeros are x is equal to 1. Because x minus 1 is repeating twice, they are called multiplicity of 2 because it is repeating twice. So you will see the word multiplicity again and again when you are using this rule, and even in pre-calculus and in algebra too. So that implies the root is repeated. So if I do f of negative x of the same function, so instead of all the x's, we will plug negative of x. So let's see how the things will go. Negative x cubed will give you a negative x cubed. And in this case, negative and negative will become positive, and the 2 is already there. So I can see only one variation from negative to positive, right? That's how you can understand how many variations are there. Let's take one example and we will figure out the possible positive or negative real zeros. So we have f of x, and the question is asking for possible number of positive and negative real zeros. So let's evaluate the f of x first. I will rewrite the function again. Now at this point, you can see how many variations are there. We have one variation here, another here, and there is one more. That means we have 3 variations. And then we can also evaluate f of negative x. So we will switch x with negative x. And if you clean this up, So in this case, all the terms, they are negative. So there is no variation, right? So we are not looking for any negative real zeros. We are only looking for positive zeros. So we can, from the first evaluation, that means the positive ones, we can say 3 positive real zeros or 3 minus 1. 3 minus 1 is 2. 3 minus 2 is 1. So only one positive real zeros, because whatever positive real zeros you are getting, that number and also that number minus 2 will be the real zeros. And we don't have any negative real zeros because there is no variation with f of negative x. 3 minus 2 is equal to 1. That's how I got 1 positive real zeros. So keeping these two rules in mind will be quite handy. So even integer implies we are subtracting by 2's. Right? Try one question on your own, and then we will move to upper and lower bound. So write this question down and give it a try. Positive and negative real zeros. Okay, now let's move to upper and lower bound rule. So when we say upper, that means the highest limit. Lower means the lowest limit between which the real zeros should be there. So we are saying f of x with real coefficient in this case we are talking about with all of these real coefficients, not imaginary, right? And positive leading coefficient, and here f of x is a polynomial function. When it is divided by x minus c, now x minus c is a linear function, right? And we can divide by using synthetic division. We have discussed about synthetic division in the previous videos. If you are not sure about synthetic division, please go and check those videos as well. And then we are looking for two different conditions. The first one, if c is greater than 0 and all numbers in the last row after you are done with the synthetic division, in the last row you are left with either positive or zeros. Then what will happen? Then c will be upper bound. If c is less than 0 and the numbers in the last row are alternatively positive and negative. In the last row means once you are done with the synthetic division, whatever is left is alternatively positive and negative. Then that is considered as C is a lower bound. So upper bound when C is greater than 0, provided last row will have either positive or 0. It will be a lower bound when C is less than 0, provided the last row will have alternate positive and negative leftovers. Let's take one example and understand it, and it will give you a refresher to synthetic division as well. So the question says, find real zeros and the function is now if you remember, we have done the rational factors or rational roots previously, we will use that method again. So with this function, I can understand that there are three variations. So I know there will be three positive roots or one positive root. Why one? Because 3 minus 2, that is 1. So if I go back to the rational factoring theorem, so we are trying to find the factors of constant, which is negative 2, and q is the factor of the leading coefficient, which is 6. Because finding the factors of these two will help us understand with what number I should use the synthetic division, right? So the factors of negative 2 will be plus minus 1 and plus minus 2. And then we can write all the factors of 6 as well. Evaluating this, and then you can rule out what are repeating, we can understand what synthetic division, what factor we can use for the synthetic division, and we can start with 1. But let's write down how many real roots are there. So 3 positive real roots, and I told you 3 minus 1, 3 minus 2, it will be 1 positive real root. For the negative function, f of negative x, we are not getting any variations. So that implies no negative roots. So we can just write on the positive roots. Let's do synthetic division to check upper and lower bound. For the synthetic division, we are writing all the coefficients. And we are trying to divide by 1. That means x minus 1 when c is 1. So bring 6 down, and then remember diagonal multiplication, vertical addition. So if you can see, all the numbers in the last row, they are positive. Because all the numbers are positive, x is equal to 1 is a upper bound. Even though the last number is not 0, that's totally fine. But all the numbers are positive because the first condition says if c is greater than 0, so in this case, c is 1, which is greater than 0, and in the last row, it should be either positive or 0. So we have all the positive numbers. So x is equal to 1 will be the upper bound. If you check this function on the graphing calculator, and if you graph it, you will find that the 0 will be between, that means 0 of this function will be between 0 and 1, because 1 is the upper bound. It will not go beyond that. You can check on the graphing calculator. And when I checked on my graphing calculator, I got x is equal to 2/3 as the 0. So it's a nice check to understand whether our answer, we are on the right track for solving the questions or not. And just keep on practicing these Descartes rule and upper and lower bound. They are wonderful way to check your answers, to evaluate just by looking at the function. And keep on practicing. I will see you in the next video. Bye-bye. Thank you for watching.